In proof number 4, it's very similar to one of the proofs on the first page. We're told that n is parallel to m, that 1 is congruent to 2, and we want to prove that line P is parallel to line R. Remember, to prove that lines are parallel, we have to use one of those 5 relationships and show that they're equal or that they're supplementary, depending on what angle type you're talking about. So hopefully you're thinking, to prove that P and R are parallel, I'm going to have to use 3 and 2, because those are the only angles that are connected with P and R. So what I need to show is that 2 and 3 are congruent because they're alternate interior. So that's eventually that step that's going to let me prove that P is congruent to R. So again, if you like to start at the bottom, just give some space because I'm not sure how long this will be. If I'm going to prove that P is parallel to R, the step before that has to be that angle 2 is congruent to angle 3. So we somehow have to take our givens and get to this point. So I know that n is parallel to m, angle 1 is congruent to angle 2, and that is given. Let's use the fact that n is parallel to m. If n is parallel to m, we know that 1 and 3 have to be the same. So we can say angle 1 is congruent to angle 3 because they are alternate interior angles. This actually ends up being a pretty short proof, because if 1 is congruent to 2 and 1 is congruent to 3, that takes us right to saying that 2 is congruent to 3 by the transitive property. And then finally, we can say that P is parallel to R. And again, remember, the thing that let us say that P and R are parallel is that 2 and 3 were congruent, because they are alternate interior angles. If alternate interior angles are congruent, then those two lines have to be parallel.